Going on to topic 4 in module 3, we're going to deal with division of polynomials. And we have examples of each type, and basically what I want to do is give you the methodology for doing them. So we see in the first examples here, we're going to divide a monomial into a binomial. Here a monomial into a trinomial. So there is a way to set this up. So let's do so. And you have plenty of room to write this out. So basically what you do is you take the 60x to the 4th and the 72x. Now instead of having it over a common denominator, you separate them so each term is over the denominator. So let's set this one up too. 20a to the 5th minus 35a to the 4th plus 55a to the 3rd. And they're all going to be over this common denominator individually. So this is 5a to the 3rd, 5a to the 3rd, 5a to the 3rd. Well, we'll give you some time. You want to simplify each one of these, and these are not difficult, they're just what they are. We use the rule of exponents. Here there are no exponents, so they stay the same, and that's what we get. Now over here, again, doing our division, this will be a positive, this term will be a negative, and this term will be a positive. And let's see what we get. So again, 5 in the 20, 4 times. We're going to bring the 3 up, it crosses the division bar, changes its sign, becomes a negative 2. 5 minus 2, or 5 minus 3 I should say, is 2. And then we figured out our sign is negative. 5 goes into 35 7 times. And then we bring the 3 up, subtract it from the 4. We get a 1 that we don't write. And then here these cancel out completely, and we get 11. Okay, these are the easy ones so long as you remember this technique. Now in these, I got a blue sheet here, it will be a nice change. We have a trinomial that we're going to divide by a binomial. So for this, we use long division. And we set it up this way, and you set yours up as I do this one. So, we now want to divide the n into this n to the second. And see what we put up here is how many times. Well, a resource might be take your n squared and divide it by n. Now when you do this division, you end up with n, and that's what you put up there. Because now we're going to go n times n gives us n squared. We then go 1 times n, and this gives us a positive 1n. Now, what do we do here normally? Well, we're going to subtract. So when we subtract, we have to change the signs. And now we add. So here, these cancel out. That's what you expect. It's a 0, and this becomes 7n. And now we bring down this 7, like so. Now again, n will go into 7n times. If you're not sure, just divide it over here on the side, and it's a positive 7 times. So n times 7 is 7n. 1 times 7 is a positive 7. Now, what do? When we put that line there, we change the signs. And on your paper, I would physically erase this so you don't get confused. And now you add. And this ends up as 0. Your remainder is 0. All right, that was a super easy one. And if you want to check your answer, just FOIL these. N times n is n squared. Outer 7n, 1n, 8n, 7. So it checks. Now here, again, we're going to set this up. X minus 4 divided into x squared. Now here's the case where there is no x term. But one of the things we must do as we go through this procedure is put in a space holder that has no value, but is the next power going down from x to the second, x to the first, and there is a 15 there. So this is an important skill. When you see your numerator and it's missing one of the powers of x, you have to put one there so that when you do the process of long division, you have a place to put things. Okay, now x will go into x squared, and again, if you don't know, x squared divided by x gives you x. So x times x is x squared. Negative 4 times x is a negative 4x. Notice you have a place to put it now. Now as we draw the line, we change the signs and add. These will cancel out. That's what you're always looking for here. And this is going to be a 4x, and we bring down the 15. Now we have 4x divided by x. This is going to be a plus 4. A way to figure out what you're going to put up here. So x times 4 is 4x. A negative 4 times a positive 4 is a negative 16. Now we're going to draw a line under it, and what do? Change our signs. So this becomes a 0, and this is a positive 31. That is your remainder. So as you put your answer in MATLAB, you have this plus 31 over x minus 4. And if you check your answers, that checks out. Now in letter C, it's a little more complicated, but let's set it up. So it's 2y squared plus 1 divided into 2y cubed plus 8y squared plus 3y minus 1. So there are no values missing, so we didn't have to put any in there. Sometimes they'll say, we'll put a 0y here, but we don't need to do that. Okay, our first thing is we have 2y cubed divided by 2y squared. And that will go in y times. So now we do our multiplication. 2y squared times y is 2y cubed. Now 1 times y, and you have to put it in the right column, is a positive 1y. we draw our line, and again, when we draw our line, we have to change signs. This is critical. So this cancels out. We bring down the 8y squared, and this becomes a positive 2y, and this is a negative 1. Now, 2y squared goes in the how many times? Well, we're not sure, so we'll do it this way. These cancel out, and this goes 4 times. So we put a plus 4 up there. Now, 2y squared times a plus 4 is 8y squared, which is what you're looking for. 1 times 4 is a positive 4 that we put in this column. Now when we change we put our line, we're going to change our signs. This becomes negative, and this becomes negative. Now that cancels out, and we end up with plus 2y minus 5. And that's our remainder, because we can't go any more. So our answer is this, with the remainder, and we just usually write it as 2y minus 5 over 2y squared plus 1. And that is our answer. So again, they're showing you a number of different kinds, some easy, some where we had to put values in, but the process is the same. And you'll need to practice to earn mastery. Let's go on to our last one. This looks just a little tedious, but basically it's this divided by that, and that's what they're showing in that funny kind of division. So we're going to set it up. It's going to be 4t minus 3 divided into this now. Now here our first term is 64t cubed, and there is no t squared, so we have to put a placeholder. There is no t to the first, so we put a placeholder for that, and then we have a negative 27. Now I don't know if you realize this is the difference of perfect cubes. And we said we factor that from an older lesson with a parenthesis of 2 and a parenthesis of 3. And whatever sign is there, we put there, and the opposite sign here. We then said we took the cube root of this, which is going to be 4t, and the cube root of that, which was 3. Well, then we said we square this, and that's 16t squared. Now we multiply these two together, and you'd think it would be a negative, but we said because of our formula it's a plus. So this is a plus 12t, and then we squared this as a plus 9. So that was the method of factoring this that we had in chapter 2, I believe. Now we're wondering, because they're giving us this, which is this here, whether we're going to get this up there. Well, let's check it out. And I'm going to erase this so it doesn't confuse us. Well, we have that technique, 64t cubed divided by 4t. Well, t goes into 64 16 times, and we get t squared. So that part looks good. Okay, so we go 4t times this is 64t cubed. Now 3 times this is a negative 3 times 16 is a negative 48t squared. So we then take our line, and in so doing we have to change both signs. So this is 0, and this becomes a plus 48t squared. And we can bring down our 0t. Now we have 48t squared divided by 4t. Well, 4 goes into 48 a positive 12 times. And we have a t. And so far, so good. Now notice we had said here that when we did that technique, we'd multiply and we think you'd have a negative, but the formula calls for a positive. So that's why it is a positive. So now 4t times this is 48. My voice is faster than my hand sometimes. And now 3 times, a negative 3 times this is a negative 12. How about a negative 36 here? Three times 12? Yes, there we go. Put our line, and in so doing, we have to change the sign. So I got a green, that's okay. So this is a 36t now, minus 27 that we bring down. Now here we have 36t divided by 4t. That's going to be a 9. Ooh, checks out very well. So 4t times 9 is 36t. A negative 3 times 9 is a negative 27. We draw our line and change signs, and we have 0 remainder. So we have just proved that the technique we use in factoring the difference of perfect cubes is in reality what you would get if you divided this, one of the factors, into this original number. But we did need to put in the placeholders, so we had places to put our values as we multiplied through. Now the proof of the pudding of this division is that you do your examples and get them correct. But this is the reference, if you need to go back and review, of how to do it.